today we're going to start talking about integer programming. And so the question is, what is the big difference between just our normal optimization and what makes it integer programming? And that really is just the addition of the integer variable when we're dealing with any of our solutions. And so what is an integer? An integer is basically a whole number. And so what we're going to do in these next couple videos is we are going to look at a couple of optimization problems that we are going to transform into our integer programs. And so we have this problem. The General Flakes company sells a brand of low-fat breakfast cereal that appeals to people of all age groups and both genders. The company advertises this cereal in a variety of 30-second TV ads, and these ads can be placed on a variety of TV shows. The ads in the different shows will vary in cost and by the types of viewers they are likely to reach. The company has segmented the potential viewers into 6 mutually exclusive categories, which we have on the next tab. A rating service can supply data on the number of viewers in each of these categories who will watch a 30-second ad on any particular TV show. Each such viewer is called an exposure. The company has determined the required number of exposures it wants to obtain in each group. It wants to know how many ads to place on each of these TV shows to obtain the required exposures at a minimum cost. And so the question is, how should the company proceed? Well, let's go here to our model. And so all of these monetary values are in thousands of dollars. As we can see, here's our age groups. We have men 18 to 35, men 36 to 55, and then over 55, and then women 18 to 35, 36 to 55, and women over 55. And the TV shows that we're talking about are Dancing with the Stars, Sunday Night Football, Big Bang Theory, Sports Center, Homeland, Rachel Ray, CNN, and The Good Wife. And so we look down here, we have our cost per ad. So for each 30-second spot on Dancing with the Stars, $140,000 and so on. And then our required exposures that we need as the company has decided. So 60, 60, 28, 60, 60, 28. So pretty even split there. And so what are we trying to do is we want to minimize our cost. So actually before we put that together, let's go back to our thing and let's identify what we have, even though I've kind of already shown it. So let's decide what our decision variables are going to be, what our constraints should be, and what our objective is. Okay, we'll start with our decision variables. Remember, decision variable, what is that? That's what I get to decide. It's what I'm picking. It's basically the answers that I am trying to find. You know, we do have an objective, but to get to that objective, we have to make some kind of decision. And that decision that we're going to make is the number of ads to place on each TV show. Okay, so we have some constraints. So we're just going to start with 2 constraints, and that's the minimum number of exposures for each demo. Each demographic group. All right. Our other constraint is going to be non-negativity. We love this one. This is going to show up most of the time because we don't want anything to be negative. So what is our objective? Our objective is to minimize cost. And so there we go. So this is the start. This is what we should do with every single one of these optimization type problems, whether it's a optimization, whether it is a linear program or a binary program, should always start figuring this stuff out. And so my prompt, I've already got this labeled out for us. So here's our number of ads purchased, and that is in our red blocks. So those are our decision variables. We're going to have to work up what the minimized cost is, and we are going to have to work up our exposures. Okay, so the first thing we want to do is let's put our range names in, because we like our range names. So I'm going to select that, hold Control, select this here. So we're going to start there, formulas, create from selection, top row because that's where the words are. And so now if I highlight that, there we go, that array is actual exposures. Because remember, we like having names for our solver block because it's nice to be able to see what's going on. So we're going to have total costs and number of ads purchased. And so that should be all we need. Create from selection. These are left column. And to make everything nice, Control B, and then range names. Control B just bolds it. Let's move this over. And then we're going to paste our list here. So formulas, use in formula, paste names, paste list. And oops, I had that all bold still. So let's go fix that. Just highlight that, Control B to get rid of the bold. And those are actually quite large. Let's get to 18. They should be 11. So let's just change that to 11. All right. I'm going to double click over here to fix the... Oh, I can't fix the heights because probably that box is there. Anyway, that should be fine. I'll just pretty this up just a little bit. So that's good enough. Okay, so we have everything set up and we're ready to go. So let's just treat this as a normal optimization problem and we'll run it there. And then we're going to do a couple different things to where we finally make it an integer problem. Okay, so our problem is we've got to figure this out. So let's put things together and we are going to be looking at our actual exposures. So our actual exposures are going to be how many ads that we buy times whatever show that we've got here. So let's just start out by putting ones in all the decision variables, because it's always nice to start with something there. And this is actually going to work out pretty easily because if you can see, well, if I've got one exposure dances stars for men 18 to 35 is 5, plus one exposure times 6 is 6, da 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 da. Well, that's obviously a sum product. So we'll go in there, we'll type in sum product, we'll hit tab, and I'm going to sum product this array, comma, with this array. And since we've named that second array, we don't have to lock anything in. We're just going to drag it down. It's all going to work out. It's going to be great. So I hit enter. And so if I go and I drag this down, then I'll click on one of these just to check to see, yeah, it looks like everything is indexing just the way that I wanted to do. It's always important to check that indexing. And, well, this is our constraint. So remember, we like leaving that space there so we can put in the less than equal to signs. So if we look at it, if we need 60 exposures, this number over here has to be greater than or equal to 60. So we're going to put that in, once again, to remind us when we go to build solver, make things easy for us, make it so we don't forget, makes things nice and ready to go. Okay, and so the last thing that we have is total cost. And how are we going to get total cost? We're going to sum product the numbers of ads purchased with cost per ad. In fact, let's go, and I should have range named this before. Let's go create from selection, left column, and then I'm going to repaste our names in. Oops, not create from selection. I'm going to go use in formula, paste names, paste list, and then for some reason, I don't know why, these ones must have been set for bold, but let's just go back, change this to 11, make it nice and uniform with everything else. There we go. So there is all of our things. We're going to come here, total cost equals sum product, do a tab to have it fill in, and cost per ad with numbers of ads purchased. Okay, so right there we've got 505, and since those are all in thousands, that would be $505,000, and that is buying one ad in each slot. So at this point, the structure of the optimization model is complete, and I think we will go into the next video and we'll build up our solver solution.